Good morning, class. As we have already started with the chapter recursion, I'll continue with the same topic. Let's have a quick glance what we did in the last class. Recursion. What is recursion? A function that calls itself from its body is called a recursive function. The syntax, as you can see on the screen, is access specifier, then the return type, then the method name along with the parameter list. Then in the method block, this method name is given again. The call of this method is called again with the parameter list. Here two very important things to understand are base case and recursive case. Every recursive function uses a condition to terminate. This condition is known as base case. Only when the base case condition is true, it will terminate the function. Otherwise, it keeps on calling the function again and again. Now, what is recursive case? The statement that calls the function repeatedly from its block is known as recursive case. Hence, base case is a situation or the condition that is used to terminate a recursive process, whereas recursive case is the function calling statement that invokes the function repeatedly unless base case is satisfied. Children, this question of difference between base case and recursive case has come many times in the board examinations. So please understand this very nicely. Next we come to types of recursion. We are dealing with two types of recursion here, direct recursion and indirect recursion. Under direct recursion, which is also known as linear recursion, we have tail recursion and binary recursion. Okay, so I'll move again to tail recursion, a recursive function in which recursive call is the last statement of the function is known as tail recursion. All these type of recursions we have already discussed in class 11. This is just an overview of what you have learnt in class 11th. An example of tail recursion is the factorial function. I hope by seeing the example you can clearly see that the name of the function is given over here and the name of the function is given inside the body of the function. That means this is the function call statement. Next comes binary recursion, a recursive function in which the function calls itself from two distinct points is said to be binary recursion. Both the function calls may be included in a single statement or can exist in two separate statements. Example, we have given an example here as to finding the GCD of two numbers n1 and n2. Please have a look. There is a class numcheck in which there is a function GCD which is having two parameters n1 and n2. If n1 and n2 are equal, then you return n1 because any of them will be the GCD. If n1 is greater than n2, then call the function GCD and subtract n2 from n1, which will be copied into n1, and the second parameter remains the same. Otherwise, the first parameter remains the same and subtract n1 from n2 and copy it into n2. This is how there are two return statements, but only one will be executed. Why? Because of the if-else statement. I'll move further. There are another type of recursion is indirect recursion. In this type of recursion, a function is called from another function block. The diagram can be seen from the book. I hope everybody is having a book. I'll give you a screenshot of the book as well after I complete with this video. Now there are a few questions which I expect all of you to do on your desktops or laptops and practice them to understand how recursion is happening. First question is, write a program to find the sum of first n numbers using recursive function. What does it mean? If I pass the value of n as 5, that means starting from 1, it will add 1 plus 2 plus 3 plus 4 plus 5. Is it clear? This is the answer. The next question is, write a recursive function to check whether the number n is prime or not. If it is prime, the function returns 1, otherwise 0.